In this video, we are going to use differentials to estimate the change in profit for a company that manufactures and sells widgets. So this company manufactures and sells widgets every week. The weekly cost and revenue equations are given by the costs are $12,000 plus 10 times the number of widgets produced, and the revenue is given by 15 times the number of widgets minus the number of widgets squared divided by 5,000, and these functions have a domain of 0 to 75,000 widgets. So we're going to use differentials to estimate the change in profit if production has increased from 15,000 to 16,000 widgets per week. And what we know is this change in profit is given by dP equals P prime of x times dx. And this x is going to be the starting place, the 15,000. Okay, so we need to figure out what P prime of x is. We need to figure out what dx is. dx is just the difference, 16,000 minus 15,000. So dx is just 1,000. Okay, so now we need to find out P prime of x. Well, we know P of x is equal to the revenue minus the cost. We know the rules of differentiation tell us that P prime of x is the derivative of the revenue minus the derivative of the cost. So we don't actually have to add this function up. We can just do it this way. All right, so derivative of revenue. The derivative of revenue is, we've got 15x, the derivative of that is 15, minus 2x over 5,000, which is 15 minus x over 2,500. And c prime of x, the derivative of c, is simply the derivative of a constant is 0, derivative of 10x is 10. So that gives us P prime of x is equal to 15 minus x over 2,500 minus 10. Now we're interested in P prime of 15,000. So that's 15 minus 15,000 divided by 2,500 minus 10. This is 15,000. This is 6. So this is 15 minus 6 minus 10, so negative 1. So we have P prime of x, we know dx, so we know that dP is equal to negative 1 times 1,000, which is negative 1,000. So our company would estimate that if production is increased from 15,000 to 16,000 widgets per week, the company's profits would reduce by $1,000.